Our next talk comes from Jim Walker, who's a recovering developer turned evangelist who loves useful stuff, cool, cutting edge tech, which just means he's well placed to talk about the things that Cockroach do. He's an advocate of the developer and an active participant in several open source communities. He enjoys translating and distilling complex concepts into compelling, simple explanations that broader communities can consume. And I guess we're going to find out whether or not Jim can actually back that up today. So I'm really looking forward to this one. Jim, over to you.
Well, I'm going to try, Sam. But by the way, first of all, you guys were talking about being at KubeCon, and well, here we are. I bought KubeCon to everybody on the stream. So thank you for that introduction. I very much enjoyed the conversation that Sam and Kelsey just had. I think some of the things that I'll talk about here are definitely related to that. Some of the complex technologies, like Sam was mentioned in that's kind of my written bio. Some of those include, well, gosh, it was the Hadoop days, but more importantly, I spent a fair amount of time at CoreOS, and I was very early days kind of involved in the Kubernetes community. And man, it's just really great to hear Kelsey talk, and the way he simplifies things is great. Now, I can tell you, when I found Cockroach DB about 5 years ago, I couldn't unsee it, and so it made me think differently about where does the database lie in terms of our application stack? Is it infrastructure? Is it part of the application? And hopefully, some of this conversation helps you think through some of those things as well. I think Sam and Kelsey touched on some of the points here, so I'll try to bring this back to there. But my session is called "Choosing a Cloud Database." Now, the subtitle here is actually pretty important. I work for a database company, so I'm just going to be me trying to be as impartial as I possibly can. Okay. So let's go. So first of all, I'm Jim. I'm principal product evangelist here at Cockroach Labs. Our booth's right over there, by the way. And my Twitter handle is James, JAYMCE. Our session is really kind of beginner, more or less. I'll get into some deeper concepts, but this is here to give you kind of some of the guideposts to think about when you're choosing a cloud database, right? But by the end of it, at the end, please stick around. There's a special surprise at the end. I'm going to give away a free book. We just published our O'Reilly guide, and while I'm at an O'Reilly event, man, best call to action ever, a free book. So I'll give you the QR code and how y'all can do that at the end. So how's that? I tease you a little bit. So how do we choose databases today? Basically, somebody sits down, they want to start coding some application. I don't know. I want to get all the birthdays for all my friends together into some database so they can all access them online, and maybe it interacts with everybody's calendar so we're all up to date. And when new kids get added to my groups of friends, I don't know, we think of applications and we just start building. And if I was to start building a new application, I would basically go out and spin up Postgres. That's what I used to do. It was pretty easy to do. It's actually already on my laptop. I'd create a new database and go for it because that's what I know. I come from the era of the white beards, like Sam was talking about, where they taught us relational databases in school, and honestly, I think like that. And so typically when people go out and do these things, that's where they start. And I think we think about our business logic or what we want to accomplish in the application, and we don't think of the complexity of the infrastructure or the power of the infrastructure and how that can actually be used to our advantage. And so I think there's so much more when we go out and choose a database, right? And I think when we start thinking about this, I'm gonna break this down into kind of three things. There's infrastructure choices. Again, what is the power of the infrastructure? We were just talking, Sam and Kelsey were talking at length about kind of Kubernetes. How can I use Kubernetes to my advantage maybe in the database? Or, maybe I just need something really simple where it's just, I'm gonna have a local instance of something that's just gonna serve people in my household. The infrastructure choices are kind of important, but it actually goes to the second part, which is what are your workload requirements and what are you trying to accomplish with that application? And then finally, the third kind of vector, I guess, beyond the familiarity you need is, what do you need to think about when you start choosing a cloud database and the costs, the available resources you have to use. And so I think it's just a subset of a lot of things that you may want to consider when you're choosing a database. And today, choosing a database to me is no longer hey, go choose a database. To me, it's choosing a database service, because ultimately I don't know of anything really net new that's kind of where people are kind of installing databases and doing all these things. It is really kind of choosing the right database service for what you want to accomplish. So let's just start with your application architecture. Sometimes we have a simple application, it's sitting on top of a database, it's kind of the simplest thing. Maybe we're going distributed. We have lots of different microservices that are all kind of coordinating together. they have to coordinate with the database to write things. What are the complications when you get to that? Or maybe I'm deploying things in this kind of, very geographically dispersed environment where, I have applications or instances of a service running in, multiple different places. And I think what we don't think about on day one is kind of this third level of maturity when I am distributed and I am everywhere. And the point of a cloud is, well, it's everywhere. It's like something we were just talking about again in the last session, right? It's a fundamentally different way of delivering, right? And so how do we actually use the database as a tool and to provide power into that application at kind of these broad scales? So understanding that it's not just you and your database, it does get much more complex. And what are some of those things, right? And so I think the next thing we think about is as we build applications and services today, we're not building kind of an app that back in the day, again, I'll go white beard on you, but back in the day, we used to build an application, we'd have make files for different environments, and then you'd burn that thing to a disk, and maybe it was like 15 disks, and you'd install that thing, and then on disk 14, the CDC check would, whatever. Like we don't deliver software in the same way. It's no longer like, hey, let's go build our app, let's sell it to somebody, they're going to download it, and they're going to actually, install this thing, right? Because it's fundamentally different the way that we want to actually do these things. We deliver our things as services, right? We used to release software, right? People used to buy it or download it, and then they would install it, right? And that was the process of which we went about these things. Well, in the new way, we don't do any of that. We actually publish it to the cloud, and the customer subscribes to the service. And then we, as the developing company, we provision that instance, and we're using things like Kubernetes to do so, like we were just talking about, right? And so this delivery method actually has a fundamental impact in the way we think about the database, because is each one of my instances of a service going to have its own database? Or do I need to start thinking about the database in a way where, oh, I have one database and it's multi-tenant? Well, how do I firewall off data from different customers? And so the ramifications of the way that we're actually delivering software today have huge impacts on the database and really that key piece of the infrastructure. And that's why I believe it's really infrastructure. I think, ultimately, I think it's not just that app data either. I think it solves a lot of these problems that we had with the old way of, like, keeping people up to date, troubleshooting issues, like controlling people who reuse software. Like, think about that. Like, you have to buy the service now. Like, we're making things consumption based, right? I don't want to pay for what I don't use. And I think the database has a key role here, not just within, say, the service. You could imagine each one of these services have their own database underneath. How do I get a central database that not only makes it's multi-tenant, but it's also a system of record for all my customers? What are their login credentials? What's their usage? How do I actually track their consumption? How do I allow them to have instances of services across the whole planet? What does the data look like? What's the metadata for your service look like? And so as we're thinking about the application and what we're building, it's no longer just the business logic. We have to start thinking about, well, kind of the meta business logic, like this business logic that's got to sit around your business logic. And I think it's one of those things I think not everybody really thinks about, but it's actually kind of important when you do start to choose a database and which cloud service is going to actually meet that for you. So I think also another key consideration is, your database is not the only thing you have. You're going to have to integrate with a lot of things. Again, I could just start building business logic and have a database, but am I going to have to integrate with a data warehouse eventually? Am I streaming to Kafka to do some real-time analytics to, I don't know, like invalidate a transaction that's going on? So what are the things that are within the database that allow you to do that? How is it going to interact simply with things like ETL, and how is it going to publish to a change feed so that I can actually pick these things up? And so understanding the tool itself and the database of how that's actually going to do that. Am I going to need separate tools to do that? Is that adding complexity? I don't think we think about that when we think just our business logic. I'm just going to spin up a document database to start building. Well, the longer term and the longer we think about these things, we can start to avoid the technical debt that's associated with really thinking about the overall architecture of how my application sits in the wider data architecture for that organization. And then, this is my favorite of all the things, right? Like, how am I going to deploy? Am I going to deploy this database next to things like Kubernetes? Am I going to deploy it on Kubernetes? Does it have an operator? Is it cloud native? And I think the concept of an operator is amazing. And honestly, Sam and Kelsey spoke a little bit about this at the end of the last session. They were talking about, how you define an operator. And I go back and listen. Kelsey gave a great definition of kind of what an operator is. But an operator is just things. It just does things that people do. literally it's called an operator because it's actually the like of a person. And so, does the database not only get operated in terms of like installation and deployment and management of these things, but is the database itself actually taking advantage of these cloud native infrastructures? Is it distributed in these sort of ways? This is the benefits of being on a show floor. I hope there's not a whole lot of ambient noise, but they're still installing Cube behind me. So, but talk about cloud native. I think there's like they aren't building KubeCon behind me. They're composing KubeCon behind me inside Kubernetes. All right. So, is your software kind of cloud native, and is the database cloud native? Is going to fit in that world? It's another question to ask of your database. Okay. So that's kind of the infrastructure side of things. We start really thinking about, I think most people start here, and most developers I know start here. They think about the workload and what it is they want to accomplish in that workload. The infrastructure stuff is like, yeah, we'll leave that to the architect or somebody else on the team. But I think there's a lot of things that we have to think about in our own business application and the logic of what we're doing that actually gets really important, and the nature of the application and what we want to actually do with it. And so let's just think about a couple of different things. And so, I always think about, how do you model data? How do you control data integrity? I lived in a world where ERDs were something that we thought about a lot. In fact, there was like a whole DBA team who, man, if you wanted to make a change to a data model back when I started coding, man, it was a big problem. But it was right, because honestly, it established a framework for the way that we were going to think about the data of the application itself. Established, a framework for how relationships look. And more importantly, it really helped us start to understand, the normalization of data. And back in the day, normalization data was important because, well, it was a performance concern, or there was a cost concern because I didn't want to like double store. And along came, these kind of general, JSON objects. And gosh, I gave up on the document store somewhere around, I think, XML, right? Because I just didn't understand, like, the concepts of the relational model kind of aren't there in this modern world of JSON objects. However, with like objects and a document store, it's really amazing because you get all this freedom. You get this agility. I can just add things. I can add as many things as I want. It's taking away kind of this control layer of kind of referential integrity or these sort of things. It adds some complexity though. Like if you want to do things like joins, or you want to actually enforce referential integrity, you're going to have to do that in your application. And so there's trade-offs on these two things, but choosing the right type of database in terms of, I always think about the traditional battle between relational or NoSQL. I think this is the world that we live in, and thinking through some of these things gets pretty important, right? There was actually, in the last conversation, a great conversation. What is ACID? I think we all talk about ACID transactions in the database, and nobody actually thinks about the I in ACID, and the I is a spectrum. Do developers really understand what the default isolation level is of Postgres or Oracle or Mongo, or even Cockroach for that matter, where I work? And what are the impacts of having these sort of things? We talked about in that last session. We just put a timer around a transaction because we wanted to make sure the data is going to be correct. We wait 3 seconds. Well, why are you doing that? Well, because the database itself isn't guaranteeing consistency. And the I in ACID is what really it's what guarantees, transactional consistency. It's the isolation level. Now, as a developer, I had no idea what any of this meant, but it has fundamental impact on your data and your application. And actually understanding these things, and more importantly, the problems that they can actually do is pretty important. So when you choose a database, understanding isolation levels is pretty important so that you can understand, am I going to have to put weights around my transactions to make sure they're correct? What does eventual consistency mean? It just means it's not consistent for some amount of time. Is that important for you? And it's really on a workload by workload basis of what you want to accomplish, or you're going to choose the right tool for the right job. Ultimately, it's my belief that, this is kind of another one of those complexities that I don't think anybody should ever have to deal with that. Let's just optimize for things always being consistent and make the software or the database deal with that. And kind of coming at it from that way, I think is the way to do it. Because do we really want developers to have to learn all these primitives and these kind of lower level concepts the same way we were talking about that in the Kubernetes world? And so, my belief is let's just optimize so that people are going to presume things, and let's let their assumptions be correct. And so, but understanding, from your database point of view, what these things are. When you choose a database, understanding these things is pretty important as well. And it really comes down to your workload. What's the eventual scale of your application? Another big concern. How many users are you going to have? How much data will there be? where will my users be? And I think on day one, we're just trying to get an MVP out the door and make the thing work. Thinking about this on day one can help you avoid legacy or like technical debt down the road once you are successful, once you do start to scale, right? And so typically there's two ways to scale. Number one, vertical scale. I just spin up a bigger machine and I get a bigger database. I got more storage, I got more compute. That's vertical scale, and that gets you so far. You spin up a new one. Typically people will get beyond that and they'll go into horizontal scaling where you're sharding a database. You just basically splitting it in two. I don't know anybody who really likes to shard a database, but understanding the ramifications of sharding in the context of your application, again, kind of important. And I think something to think about when you're choosing your database. Is there other ways of doing these sort of things? And then what about regional scale? Am my users going to be everywhere? Can I do reads and writes from everywhere? Is there a single write master maybe in one region? What might bottleneck? Like, there's lots of different things to be considered. Does that even matter to my workload? And understanding the read volume and the write volume and where that's going to happen with a workload, actually pretty important for choosing a database too, because like I said, it may not matter that you have low latency or high latency writes. It's okay. Really, it depends on your workload and what you're trying to accomplish, and if you have geographic scale or not. But I think another one of these things is how am I synchronizing data between regions? Again, it's kind of one of these complexities that you don't really get to until you're actually scaling beyond, say, a single data center, a single AZ, whatnot, right? And then, gosh, oh boy, what about users when they are all over the planet? What are my latencies from Brazil all the way to servers in the EU or the US? And is that affecting, the application logic? Because sometimes there's timed outs and that sort of stuff, right? And so, but what's worse, what about data privacy or compliance? Maybe, there's a regulation in a jurisdiction where it requires you to store data in a particular location. Are you doing that in your application, or are there databases that can actually control that for you? Sorry, that's me not being impartial. So you let the database deal with that kind of stuff, right? It makes sense. Let the data layer deal with those sort of things, right? And so these are all kind of other issues that, from a workload point of view, that are complexities that we just don't think about on a day one. And then finally, or not finally, actually, there's a couple more. What are your uptime requirements? Can you survive a failure? Because God forbid, an entire region of one of the cloud providers goes out. Can you actually survive that? What is your failure domain? And is it the same for all your data? What's your failure domain for, is it a rack or is it a server? Is it an AZ? Is it a region? Is it an entire cloud provider? Is it a Kubernetes cluster? And I think understanding failure domains is actually pretty important because, how do you come back from these failures is difficult. Like, there's concepts in the SRE world of RPO and RTO, and how do you actually, how long does it take for you to get back online? Are you losing customers? Are you losing data? These things actually get pretty important from your workload point of view. But really, is that applicable to all your data at the database layer, or is it at each table? Do you have different uptime requirements? We can start to think about it in that way. What about planned downtime? What if I'm going to upgrade the database or I'm going to upgrade my application? How do you do that? Are you planning to do that at 3 a.m. or can I do that in the middle of the day and do rolling upgrades like a Kubernetes does, right? And so thinking about requirements, thinking about your team, your workload is critical on that side too, right? So those are all kind of more technical concepts, right? Like the infrastructure and how you're going to deploy, the workload itself, and what do you want to accomplish with your business workload will help depict or help you decide kind of which database you want to actually use. But there's also this resource thing is actually pretty important, right? I think open source is kind of one of these ways. People think it's like free. We always call it like free beer versus free puppy. I've been in the open source game for a long time, and sometimes it's free puppy, man. There's a lot of work to do with this thing, and how do I service it? How do I support? I think that the cloud services have taken away all of that nightmare of managing databases. I think a lot of that, like I think scale is still an issue. I think resilience still gets difficult with many of the cloud services. But understanding those sort of things and coming into it up front and understanding like what that's going to mean to you. Is my cloud service supported? When I do have issues, is there a Slack channel? Is there a phone? Is there email? The typical things that we need when we think about deploying software gets pretty important, and something I believe you should consider when you're choosing a database. Again, that's the topic here. But there's also kind of other kind of costs, and understanding like the total cost around these things, right? So as a cloud services, am I expanding storage or not? Is that part of the cloud service? Am I, are they adding that on? What about IOPS as data starts to move? What about multi-region and the egress costs as I start to move things? Or how are backups managed, and what are they going to cost me? And then, gosh, all these integration points. Do I need extra tools such as CDC and ETL? How am I integrating with data lakes? Is my data science platform going to integrate with this thing nicely, right? And so there's just a lot of cost around not just kind of the extra tools, but the people that you need to actually do this as well. Do you have the SREs and the admins to actually deal with this thing? Do you want your developers dealing with, like, referential integrity, the cost of that time and the people? Can you go out and hire these resources, right? The beauty of a cloud service is you abstract that away, and diminish the time it takes to actually manage these things, but avoid downtime and uptime. And what are the costs around those sort of things as well? And I think, again, more cost considerations, because we're going to talk about what's the overall things. Well, cost is definitely one of those things when you're choosing a database. I understand. Look, at familiarity, I think we all go out there, that's where we first go, but lots of other things to talk about. So here's 9 questions if you want to talk about this, right? So I'll leave them here. I'll distribute the slides, but I wanted to get to my last slide because there was one thing I wanted to do before we go. Oh, by the way, I am the sponsor here, so I would be remiss if I didn't talk about Cockroach. Actually takes all that stuff we were just talking about and simplifies it down. Scale is spin a node, you get scale. Resilient, it's distributed consensus. It could survive the failure of anything. It's going to tie data to a location. It's going to guarantee consent. All those things would lead me to this one slide. But more importantly, as I promised, oh, by the way, and you can start a Cockroach DB instance right now, actually the serverless version, which we were talking about a little bit earlier. But most importantly, I did want to actually thank you all for sticking around until the very end. QR code or the URL for the old school peeps who want to type it in, but we're giving away our definitive guide. We're so happy to publish this with O'Reilly over the past week. And so feel free to go and download our book if you want to learn more, or ask me and I'll get you the presentation slide. So thank you, everybody. I think I was just right at 20 minutes, but I really, really appreciate it. Thank you very much.